Today, we're going to tell you a story. It's a story about our next-door neighbor in space, Mars. And it's a journey that starts with us just looking up at a little red dot in the night sky.
And it ends, or at least brings us to today, with robots literally driving around on the surface of another planet. It sounds like something straight out of a movie.
It really does. You know, there's this quote that just captures that feeling perfectly. Imagine a place that is rusty red from space. Imagine valleys carved like dried riverbeds. Now open them and know it is real. That world is Mars.
Wow, that actually gives you chills. It really makes you stop and think. We're talking about a real, physical place, not just a light in the sky.
Exactly. And you know, for most of human history, that's really all Mars was. A little red star that seemed to wander across the sky. We gave it names, we told stories about it.
So what was the turning point? How did we go from seeing just a dot to understanding that it's actually a whole world?
Well, the first huge leap forward came with the telescope. I mean, for the first time ever, we could see details, and what we saw was amazing. These bright white caps at the poles that would get bigger in the Martian winter and then shrink back in the summer. It was our very first clue that Mars had seasons, kind of like we do.
Okay, I get seeing seasons from a distance, but how on earth can we know what Mars is actually made of? I mean, it's millions of miles away.
That is a fantastic question. And the answer is this really clever science called spectroscopy. Basically, you can take the faint light from a planet, split it into a rainbow, and hidden in that rainbow is a sort of chemical barcode. That code tells you exactly what gases are in its atmosphere.
So once we read that barcode from Mars, it told us that the planet has a really, really thin atmosphere. And that atmosphere is almost all carbon dioxide.
Huh, carbon dioxide. Isn't that what plants on Earth breathe? So were they thinking they'd found Martian forests?
You'd think so, right? But no. Scientists figured out pretty quickly that the air on Mars is just way too thin and it's way too cold to support life as we know it. So that carbon dioxide was a big clue, but it didn't point to what people were hoping for.
To find out more, we really had to go there. We couldn't send people yet. That was still way off.
But we could send the next best thing. We could send our robotic eyes and hands. And that's what kicked off the whole era of robotic exploration.
And we didn't just dive in head first. There was a really logical step-by-step approach. First, we sent missions to just fly by and get a quick peek. Then came the orbiters, which mapped the whole planet from up above. After that, we sent landers to actually touch down and test the ground in one specific spot.
And that all led up to the rovers, which are pretty much what they sound like. These little robotic geologists on wheels that can actually drive around and explore the surface.
Okay, that's a lot of incredible missions. But can you just break it down for us? Just a few simple, direct comparisons to help us get a feel for what Mars is actually like next to Earth. Absolutely. Let's do a quick side-by-side. First up, size. Mars is actually a pretty small world. If you put it right next to Earth, it's only about half as wide.
So a much smaller planet to explore. Got it.
Okay, next, the air. The atmosphere on Mars is incredibly thin. We're talking about 100 times thinner than our air. Only about 1% as thick.
Wow. So you couldn't just take a deep breath. You would definitely need a spacesuit just to survive the lack of pressure.
Right, and here's a fun one. Even though Mars is smaller, it goes big on its landmarks. It's home to a volcano called Olympus Mons, and it is the largest volcano in the entire solar system. To put that in perspective, it's almost 2.5 times taller than Mount Everest. It's a true giant.
But you know, maybe the single biggest, most game-changing discovery from all of our robots was this. Mars wasn't always the cold, dry, dusty desert that we see today.
The planet has this whole hidden history. And that story, it turns out, is written in water.
But how can we know that for sure? I mean, what's the actual concrete proof of all this ancient water?
Well, the amazing thing is that the clues are basically everywhere you look. Our orbiters see these huge dried-up river channels that are carved right into the landscape. Our rovers have found clay minerals and different kinds of salts in the rocks.
And those are things that, here on Earth anyway, only form when they've been sitting in water for a really long time.
Exactly. They see rocks with layers that look just like sediment at the bottom of an old lake bed. And believe it or not, we've even found clues inside chunks of Mars that have crashed down on Earth as meteorite.
So, if Mars had all this water, where did it all go?
Well, a lot of it is actually still there. It's just frozen solid. Our orbiters have found these enormous sheets of water ice buried just a little way beneath the dust. They can use a kind of radar that works like an X-ray, letting us see this hidden ice deep underground.
So, discovering that Mars had this warm, watery past, well, that naturally led scientists to the next, much bigger question. In fact, it's the question that drives pretty much all of our exploration of Mars today.
And it's a question that's so simple to ask, but just unbelievably difficult to answer. If Mars once had water, could it also have had life? That is the question. And we need to be really, really clear here. As of right now, we do not know the answer. We have not found any proof of life on Mars, past or present.
So, what are scientists even looking for? How do you search for something like ancient, microscopic life on another planet?
Well, the first step is to look for something called organic molecules. Now, these are the chemical building blocks of life as we know it, things based on carbon.
And finding them is a really great sign.
But wait, it says here they are not definitive proof of life.
And that's the key thing to remember. Because it turns out non-living things, just regular geology, can also make these molecules. So finding them tells us we're probably looking in the right kind of place, but it's not the smoking gun. The search has to go on.
Okay, so if finding those building blocks isn't enough, then what is the next step? How do we actually try to find a definitive answer, one way or the other? Well, the current plan is honestly one of the most exciting and ambitious missions ever. The Perseverance rover is right now drilling into the most interesting rocks it can find, taking these little core samples and sealing them up in special tubes. The goal is for a future mission to go there, pick up those tubes, and bring them all the way back home.
So for the very first time, we'd actually have pieces of Mars here on Earth where we can study them in our best labs with our most powerful instruments.
Exactly. It really brings this entire story full circle. I think this quote sums it up perfectly. When you look up at the red dot in the night, remember, this is not a story from a book. It is a planet with a long past and more to tell.
It's just incredible to think about that journey, from a mysterious dot in the sky to a world we can actually sample and bring back a piece of.
And that really just leaves us with the biggest question of all. What secrets are waiting for us inside those rocks? What will the next chapter of our journey to the red planet finally reveal?
Yeah, the story is definitely far from over.